really cool, which is going to solve a lot of problems that you have with your Terraform CI/CD deployments. So I'm really excited to be on here today with Sören, who is going to talk a little bit about how Terramate helps us to solve CI/CD problems with Terraform. Sören, great to have you on the show.
Yeah, thanks for having me. Good to be here.
So, what problems are you solving with the stuff that you have been building? Tell us.
Yeah, so Terramate comes with two components, a CLI and a cloud. The CLI helps you to organize, orchestrate, and automate all your infrastructure code. It has support for Terraform, OpenTofu, and a bunch of other infrastructure as code tools. And then we're building Terramate Cloud on top of it, which basically is a platform for better collaboration, observability, and visibility when operating infrastructure as a code at any scale.
Wow, so the first thing already caught my interest, right? We heard a lot about OpenTofu versus Terraform in all of these conversations in the past few weeks or month. How can you support both of them? What's the idea behind that?
Yeah, and there's this whole philosophical question behind whether to use Terraform or OpenTofu, which is, I think, as its own topic worth the entire podcast. But the way that we support this is basically Terramate at its core is an orchestration tool, meaning that we can execute and support whatever infrastructure as code tooling because we don't wrap. Other tooling in that space that is pretty well known, for example, would be Terragrunt. And I do think that Terragrunt has support for OpenTofu as well, by the way, but they are hard wrap around Terraform, which force you to move out of native environments. So for us, we basically in the CLI in the open source support a bunch. Would be Terraform, OpenTofu, we talked about those, but then also Kubernetes, Pulumi, CloudFormation. Whereas in the cloud, for now, we focus on Terraform as well as Pulumi. Yeah.
Okay, cool. So what I understand is Terramate provides on one side then CLI, and I hope that we can have a short look on how this actually works and how you use that. And then there is also a Terramate Cloud version where you get actually some overview and visibility into how CI/CD pipelines are being executed, right?
Yeah, correct. So the problems that we solve with the CLI basically helps you to better organize your Terraform code in a sense of splitting resources and deployments up into stacks. So the problem that we solve here is that traditionally, if you manage all your infrastructure in a single infrastructure as code base, so let's say the examples that I'm taking here all the time and I'm using all the time is VPC database, Kubernetes cluster. Now every time I touch my code base, those would all be deployed sequentially, right? Terramate helps you to split this up into isolated stacks, and now if you have those isolated units, it means you can introduce changes to all those components separately and deploy them isolated and in parallel. So organizing of code into stacks is one thing that we solve. Orchestrating the execution of commands in those stacks, such as Terraform plan, Terraform apply, would be the second. And then yes, Terramate can also run in automation. So you can use the CLI to come up with GitOps automation workflows in any CI/CD, GitHub Actions, GitLab, Bitbucket pipelines. The fourth thing the CLI is doing is then code generation. So generating code inside your stacks to keep them dry, such as Terraform configuration, provider, and backend and whatnot. Yeah, I can give a little bit of a demo how the CLI works, and then also show how this, directly translates to the cloud. So
yeah, let's do that, and let's have a deep dive on what the CLI actually is capable of, right? Yeah. And I would like to invite you to contribute to our open source project around Progen pipelines, which I also recently highlighted, to have a possibility to integrate the CLI there as well. That would be great. So let's jump over to a CLI demo. What the hell? How does it work? Why do I need a separate CLI?
Awesome. Let's do this, and hopefully you can see my screen right now. So what we talk about now in the repository for Terramate here is available at, let me zoom in a little bit, at this GitHub organization, Terramate.io, Terramate.io, and Terramate comes with pretty comprehensive documentation, and it also elaborates a bit on the problem statement, what this actually is. So the CLI, as written here, is an open source orchestration tool that helps us to unify, simplify, and scale all our infrastructure code, tools, and workflows. And I wanna show a little bit and dive into the details on how we do this. So I have an example repository here that basically is an Terramate project that manages Terraform, and I would love to demonstrate some of the concepts. So we already, and interestingly, we also do have documentation here, of course, which guides you through all the specifics of Terramate, what projects are, what stacks are, how the orchestration works, change detection. This is pretty comprehensive and can do a lot. I will not be able to cover everything here, but it's focused on the main value proposition, which is stacks. And stacks in Terramate basically allow me to isolate a bunch of infrastructure that is to be deployed and managed in an isolated manner, right? So stacks always contain of at least 3 components, which would be the actual infrastructure code that deploys and describes infrastructure, configuration, as well as the state. And in Terramate, to create a new stack, I basically have this Terramate create command here. And you see, based on my IDE, I've done it a bunch of times before. So now what this will do, this will basically create a new stack in stacks AWS VPC. And we can see that this also happened here. So now what happens is I basically have a stack.tm.hcl file in here, which is a configuration file to configure a Terramate stack, a stack in Terramate. And the language that we use here as the configuration format is built on top of HCL on HashiCorp's configuration language. At its very core, this only sets the name, a description, and ID of a stack, which we call metadata, and it's unrelated to Terraform. So a stack does not necessarily need to manage Terraform. It can manage OpenTofu, it can manage Kubernetes Manifest, or even both. But what you can see here also too is we have automatically generated upon creation of the stack, basically the Terraform backend configuration file here, and the Terraform configuration file that configures the Terraform version.
Okay, so the default infrastructure as code provider today is Terraform that Terramate CLI uses?
No, it's not. Terramate is ISC agnostic, but in this specific example, I'm using Terraform. And the reason, so if I was to work in a plain field project, those files would not be generated for me. What I basically did here is, this is a boilerplate repository that's available in our GitHub to get started with Terramate on AWS with Terraform. There's basically a bunch of Terramate configuration in here, such as automated generation for those files. So this is a feature in here that is called Generate HCL, where we say like, hey, in every new Terramate stack, just generate those repetitive Terraform configuration files for me in order to keep them dry. It's an additional feature, so the code generation is an additional feature of Terramate, and it supports various languages, Terraform just being one of them, of course.
Okay, got it.
So now if we look at this, stack, this is basically an isolated Terraform environment, right? What I could do here now is I could add a main.tf file, and then if we go back and let's say Terraform AWS VPC resource, we would see the docs here for the AWS provider. Just copy this code and put this in here. And so now what this means is this specific stack is an isolated environment in the sense of it has its own state. So it can be deployed in isolation. And the way that this works is, so now technically I could go in here, I could cd into this directory, right? And I could just run Terraform init, Terraform plan, or Terraform apply, okay? Because it's an isolated environment. But for me to do this in a more convenient manner, I can basically use a feature in Terramate that we call orchestration. And orchestration is used to execute a bunch of commands inside of stacks in our example would be Terraform. So let me do a few things here. Quickly need to log in to my 1Password. Because what we do here now is, oops, wrong password. What we do here now is basically deploy real infrastructure. And now what I want to do is,
so this means Terramate has something like one single sign-on support as well built in through the CLI.
So this is just the 1Password CLI command. And I do this to not have the audience here watch my AWS access keys. So what I'm doing is basically I call 1Password to inject those credentials to Terramate. So now there's a tool that is called AWS Vault, and AWS Vault basically pulls those credentials from 1Password, puts it into Terramate. Now what I can say is I can say Terramate run Terraform init. So if we were to look at this without AWS Vault, of course the command that we would need to execute here is Terramate run Terraform init. And now to pull the credentials, which is somewhat unrelated to Terramate, but I'm using this in this example. We follow this command. Let me put in my password here, if I remember it correctly. Yes. So now what this does is, and we can see this here, Terramate basically detects that there's one stack, and it enters the stack, and it runs this command Terraform init inside. And then we'll jump to the CI/CD part in a minute, just to elaborate on the basics here. So now
the same thing would be working for CloudFormation or CDK or Pulumi in a similar way, right?
So I could also just say, hey, Terramate run Pulumi up. And the interesting thing is that this run command here, I can set a directory. I can just say, hey, run it command directly in this specific stack. Or I can say, hey, filter by tags, and now only execute in all stacks that manage a bunch of Terraform. But it's a little bit too advanced for this demo. But basically, I can execute commands in stacks following certain filter criteria. Another thing here that is important is change. Change basically only takes stacks that have changed in my recent command branch or pull request, which is important for the CI/CD, which we will show in a minute. So now, cool. I can also deploy this, of course. So let me run Terraform apply. I'll do this real quick. Takes a second. We roll this out. Of course.
Okay, but I still get access to the underlying log files of the corresponding tools. That's the important piece as well.
So what this does, and there was an error. Let's see. Maximum number of VPCs have been reached. Okay, that's unfortunate for the demo. I didn't clean up the account. But what this essentially means is Terramate goes into this stack and natively runs Terraform, and it would still natively give you the Terraform plan output, etc. So it just orchestrates Terraform in stacks that actually contain changes. If I so we'll not deploy this now because obviously my AWS account is full of VPCs. But what I can do here also, I can just create secondary VPC, which then would mean now I have two stacks. Let's add another main.tf file here. We just give this one another CIDR range. So now if I say Terramate list, this gives me a list of all stacks. We can see now I have two, right? And if I was to run Terraform init, now we can see it basically jumps into the secondary VPC first. And that's because the ordering in Terramate per default is based on file system hierarchy, right? So alphabetically. And once it ran init in here, it will jump into this other directory in this other stack. And those both are basically isolated Terraform environments. So now, because Terramate has those commands Terramate run that accept a bunch of parameters, for example, changed, in order for me to detect what stacks contain changes, in this specific example, of course, both, it allows me to detect and run this in CI too. And basically, one thing that we can show here is I have those workflows here in my example, whereas I have a plan and I have an apply workflow. Those are basically pre-configured workflows for Terramate that run in GitHub Actions. We have those available in the docs for GitHub, for Bitbucket, and whatnot. Because the main challenge is, of course, to automate all of this.
Of course.
Terramate also comes with a feature that's called workflows. So we can abstract common commands here. For example, Terraform init with a log timeout as a command that we call Terramate run script Terraform init. So this would run Terraform init, but with all those parameters, or Terraform plan with piping a plan to out. Anyways, let's open a pull request here and show how this works in automation. So what I can say is I can say git checkout, create a bunch of VPCs. And now what I want to do is git add stacks. Let's only commit the stacks in this case. Git commit add a bunch, add to example VPCs on AWS. Unmerged files. And then we do reset GitHub. So, yep. Okay, let's run this again. This is committed now, and I push this to the Git repository, to GitHub repository. Origin, create.
Okay, so the Terramate CLI changes the way that you can execute commands locally, because it orchestrates the deployment and manages changes of deployments if you execute this locally. That's the main kind of thing that Terramate CLI adds, I would say.
Yeah, exactly. So Terramate allows you to come up with workflows that can either be executed locally on automation, meaning the developer has the same experience than you would use in CI/CD. So you can abstract those. Terramate CLI also helps you to split up your infrastructure code into isolated environments. And also, too, it helps you to run and execute commands into those environments, aka stacks. The last thing it does is it can generate code that we've seen here, backend.tf, main.tf in stacks. So what's the overall value proposition? Split up your large infrastructure as code environments into smaller isolated units. Understand which of those contain changes to only execute those either locally or in CI/CD with uniform workflows and API that you can define with Terramate.
That makes sense. Okay, and cool. And now we push this to GitHub, and
now we push this to GitHub, and then if I go into the specific repository here, we can see there's a new branch push. So now what I want to do, I want to basically open a pull request, and this is where it gets interesting, and say, hi, this is just an example, draft pull request. So now let's zoom out a little bit. What will happen in a second now is that the CI/CD, and this is important to understand, Terramate is not in CI/CD. Terramate can run and help you to orchestrate and automate Terraform and any other infrastructure as code tooling in your existing CI/CD, such as GitHub, Bitbucket, GitLab, etc. So what this now does, it basically triggers a workflow, which is called preview changes. And this specific workflow, we can see this here, preview of Terraform changes in the last commit. And this is basically the commit that I added here in order to introduce changes. So if we look at this pipeline, what this does here, you can see the pipeline does a bunch of things. It installs Terramate and Terraform. It lists the stacks that have changed here. It also configures the access to AWS. and then it runs the Terraform plan for the stacks that contain changes, and generates a preview that will be available if we go back to the pull request in our pull request once this pipeline finished.
Okay, but this is a standard GitHub action at the end that also you could now implement in another CI/CD tool in general.
Yes,
okay,
that is a standard GitHub action. All this GitHub action does though is instead of the GitHub action detecting any changes or deciding on where to execute Terramate, all it really does is calls Terramate run.
Okay.
And now I could do the same, execute the same logic locally on any other CI/CD. So what this does here is you can see this. It basically gives me an overview of changed stacks. And of course, both stacks have changed here because we only have 2 that were introduced. And then it shows me the actual resources that are planned. So the both VPCs that I want to create here, 10.10 CIDR, right, and then 10.0. And if I was to put this on ready for review, and then I merge this back to main after an approval. Unfortunately, there's no one around right now to approve this. But if I was to approve this and merge this, then on merge back to main, Terramate would detect that, hey, this is now a merge commit, and it would run Terraform apply instead of Terraform plan to roll this out. So now that's sort of the basic workflow on how you use Terramate. So again, it helps you to split up your code, come up with those. This is really GitOps, like basic GitOps kind of workflow that we've seen here, right? You can, of course, push this to another level and say you want to have mandatory reviews by a certain amount of people, depending on what stacks change, etc. So now this is great. But if we were to work into with a bigger team, that becomes hard to oversee at some point. Yeah. So let's say you have a repository with hundreds of stacks, hundreds of deployments every day. Now what you need is a better way to understand what's going on in the platform and how those deployments look like, drift management, better observability. And that's sort of where Terramate Cloud comes in. So the way that this really works is, and let me quickly stop sharing my screen so I can pull this up here. Because I quickly prepared an excellent execution diagram right before this call. So
of course, we need to at least visualize the things that really work.
So the way that this works is Terramate, when we already discussed this, executes either locally on CI/CD for you to orchestrate commands such as Terraform plan.
Can you zoom in a little bit?
Oh yeah, 100%. Sorry. Is this better?
Yep. Okay,
so Terramate CLI as the open source tool executes locally, right? Or in your CI/CD. And then what Terramate CLI can do, it can authenticate with your cloud account with a single login. That's Terramate Cloud login, or by you providing it with an OIDC authentication. It orchestrates commands such as Terraform plan, and it sends the output of those commands to an API, which is the Terramate Cloud API. So now this API, we have a dashboard that sits on top of it, which basically provides observability, deployment metrics, etc. It can send those as feedback to your pull request in GitHub, GitLab, etc. Or it can also send notifications to Slack, Teams, and whatever communication tool of choice. So the way that this works and that this looks like, let's look at a dashboard here, which is basically the way that this is basically a dashboard that we use to manage our own cloud. So what you can see here is gives me an overview of all my stacks. And at the moment, this is an example cloud of ours, we have like 594 healthy stacks in here. 0 that have failed. Failed would mean the deployment failed for whatever reason, an error that occurred, and 1 drifted, right? I can also look at the stacks here, and you can, for example, see this is important to understand. Oh, there's a drifted stacks. A drifted stack and was attacked 7 hours ago, which is a Terramate checkpoint API. So now if I look at the stack, I can basically see the reason here, which is a Terraform planet. It's coming from Terramate CLI, why this is drifted. I can also see the latest deployments, and you see the actual time that it takes to deploy the stack, which is Terraform reply is not much, because the resource that are because of the split of resources. So I can also see the drift runs, like when did we run drifts on the stack and did we actually detect changes. So here you can see that was a drift detected. What I can do is,
and this uses the information that comes from the CI part of it, right? So there's a workflow somewhere executed, and then there's some metadata pushed to Terramate Cloud, which is what we actually see here.
Yes. So it can receive data either from your local workstation or from CI/CD. It doesn't matter. What matters is that Terramate. So if we were to go back to my CLI here, and I can run Terramate Cloud login, this basically opens up a login to Terramate Cloud. And if I log into the CLI, now everything that I do automatically gets synchronized to Terramate Cloud.
Okay, got it.
You can, of course, disable this for local workstations or say only sync certain operations. But Terramate...
Okay. And this would then, and just trying to understand, right? Would this now also then show me the different steps of a deployment or the way where it is at the same time?
Yes. It shows you the different stacks of deployments. I will go to this in a minute. So right now we're in the stack view here. This basically just gives you an overview of all stacks. And what I wanted to emphasize on is like, there's a link to this specific stack here in GitHub. And you can see, oh, it's this directory. And it also has the stack.tm.html that we've seen earlier. So if I look into this and I see, oh, it has a name, description, metadata, ID, going back to the cloud, it actually shows me exactly the same metadata here. So the name, description, which I haven't really configured here. And it says when was the stack seen for the first time and when was it last updated. So now if I go to deployments here, what this actually does is, zoom in, zoom out a little bit. And you can see here, it basically shows me what stacks are touched within a single deployment. In this specific example, I deployed a new stack, ISC AWS, which I think is a GitHub deployment. So I created a new repository here. So basically, inside deployments, I understand.
Can you go? Yeah. What about activity there? So it says coming soon, right? So So from a CI/CD perspective, what would be lovely to see right now is really when and how, which kind of updates have been performed on this specific through this specific deployment, but obviously also for this specific stack, right? Because
So we haven't finished this activity graph yet, but it's exactly what's coming here to see what resources. So what exact resources are managed here and how have they changed and evolved over time, and the same for activity. What Terraform operations did you run in here? Was it a destroy? Was it a plan? And that's helpful because quite often, let's say you merge back to main, a deployment fails. No one really sees that. Right? People see that if they look in GitHub Actions and then they're like, oh, something failed here and I need to fix this. The idea is, of course, to give you a good overview here of how this developed retrospectively over time. So that you can, so the logs are already in here, for example. We can already see whatever happens in a single step, but we want to have this as an activity graph in the foreseeable future. And basically, there's more stuff coming. There are policies coming so that you can restrict whatever you can do in stacks and also in a sense of activities, the deployments that you can trigger and stuff. But it gives you a pretty good overview and visibility into how your deployments and how your infrastructure as code develops over time and evolves over time. To see there was a deployment 2 weeks ago and a changed resource ABC caused more cost or caused potential security issue, and that's what we're sort of building. So the product is early, and we've been building this for the past couple of months. But I think what's pretty nice here is that you can add this additional layer of visibility, observability, and then also collaboration by just not invoking Terraform directly, but to have Terramate CLI invoke it. So all you really need to do is let's say you have an existing CI/CD pipeline, all you really need to do is, instead of invoking Terraform directly, you need to invoke it with Terramate. Nothing really changes. Your code doesn't need to be changed. There's no big migration effort. It does this automatically for you. And Terramate can be used in existing Terraform projects and existing Grunt projects to add those capabilities to those projects, if that makes sense.
Yeah, that makes sense. And that looks really interesting, especially because there is also a possibility, as far as I understood you, to have different types of infrastructure as code kind of pushing into this overview. And this can be very interesting from an organization perspective, right? If you have different teams using different EIC providers and you don't really have a common place, then this dashboard could become essentially that.
There's another thing coming that we haven't finished yet, but basically we're adding, and I think we need to do that, but we're adding AI capabilities here. So, for example, a Terraform plan on Terraform apply fails or on kubectl apply fails. Oftentimes, the normal developer has a hard time understanding this. Why does it actually fail? So we're building a Terramate AI in here. Basically, let me see if I can find that. That basically gives you the capabilities to explain those things, right?
Okay. So it gives the user a hint at what failed and what happened at the end.
Exactly.
Okay.
And what we want to achieve here is basically let me see if I can find this. Is basically collaboration on. So let me see this. Yep. So better collaboration on actual plans and how those change. So I want to quickly see if I can find this here for you.
So I think, Sören, we are kind of, I think I get the idea. I would not want to go into the details of all of this AI stuff because I know it's a buzzword. I personally, I don't believe in it yet, right? There's going to need to happen a lot of things to convince me that it's really going to change the way that we work, right? It can give us some hints, but I don't think that it will change directly everything that we work. More interesting for me is, will you be able to solve one problem that I see? So I've been using Terraform. I never liked it because what I miss with Terraform is that you never ever see what is the current status of deployment initiated by one of the stacks. You only see that in a Terraform output log file, which is something I don't like. If I use CloudFormation as an example, and you know that I'm on the AWS side, right? I can go to the AWS console and I will always see which resources kind of are combined together. And now I can see that resource tab up there in your screen, right? Is this essentially going to solve my problem with Terraform?
Yes, that's exactly the idea. So the idea of stacks is to give you a comprehensive overview of resources managed in stacks, the deployments that you manage for stacks. So when was it last deployed? How many deployments did it have? How does the cost or the service integrity develop over time? So it's a very good point that you bring here, and that you bring up here. Basically, this should be a similar experience in a sense of tighter grouping and better visibility, and by still being able to use Terraform, which sort of owns 80% of the market, or at least of the ops market. And that's exactly the idea here. And also too, all of this is just an UI, but all of this is visible in the CLI, right? So you can use the CLI to list your stacks, and it will basically show you what stacks are drifted. You can also use the CLI to search for specific resource. So let's say you want to see what stacks are managing Kubernetes clusters. You can do this with the CLI. You will also be able to do this with the cloud.
Okay, yeah, that sounds really interesting. As I said, I've been not liking Terraform because of that missing kind of thought on how do things behave together, right? You see just the resources deployed, but you don't see how they are combined at the end. And using Terramate to do these deployments might then even help going forward to visualize that. So now, before we kind of wrap up, how do you solve the licensing challenge with HashiCorp?
Yeah. And that's a good question. So the licensing challenge that, or to maybe give the audience a little bit of context, HashiCorp changed to a business source license from previously open source license in, I think, versions newer than 1.6 or from 1.6 on. I need to check this actually. And what they basically say is you cannot amt or host Terraform anymore in offerings that compete with HashiCorp Cloud. So the way that we solve it is by simply we are a partner of HashiCorp, right? And we went into early conversations to talk to them to make sure that there's no competition, because we're not a runner, we're not a CI/CD platform. By the end of the day, Terramate, the idea is to also get this integrated in HashiCorp Cloud with Runtask, so that you can integrate existing Terraform projects from HashiCorp Cloud to Terramate. On a more technical sense, we don't amt or host Terraform, right? What we do is we have a CLI that takes output parameters and output data from Terraform, Pulumi, whatnot, and pushes this to our cloud. But we technically don't reuse any of the Terraform components in here. So in a very technical sense, it's not even up to discussion if we were to violate license, because we don't use any Terraform specific components.
Yeah, but at the end, it's important to have that conversation as well if people are looking to adapt this or to give this a try, right? So that's why I was mentioning it.
Yeah.
So thanks a lot for those explanations. So now I already gave you a call to action, which is get involved in project pipelines. What would you give our listeners as call to action? What should they do next after watching this information around Terramate? Sorry.
Yeah. Perhaps we need to change the name at some point.
Maybe.
So I think we discussed a lot here, and Terramate is like kind of so powerful that it's always hard to wrap up all the capabilities into a single sentence. It's something I've been struggling with ever since. However, we have a pretty good a quick start guide that allows you to better understand the value that it adds to your projects with the 5 minutes, with 5 minutes of your time invested. So you should do that. You should give the repository a star. It's open source, if you like it, of course. We also too have a community on Discord that's pretty vibrant and fast growing, where people not only answer questions all around Terramate and Terraform, but basically all ISC related matters. So feel free to join there too. You can get in touch with me and our team directly. And other than that, if you would like to learn more, I'm always happy to talk and learn about your problems. Again, Terramate is it can be applied in 5 minutes. You can onboard it to existing projects in even less time with a single command. So it's quite flexible, and I assume to a lot of projects, especially at a certain scale, can add certain value. So maybe worth investing some time and giving it a try.
Yeah, and if people would like to get access also to Terramate Cloud, I guess reaching out to you personally would be the best approach.
Terramate Cloud is already, so you can already sign up. We're changing the messaging on the website this or next week, let's see. But it's basically available to the public now. If you want to get started, best is always to book an intro onboarding call with us, so we can get you up and running in no time, though. Yeah.
Cool. So how can people find you? I think I'm going to add the GitHub repository and the homepage itself. But what's the best way of reaching you?
So reaching me, there's direct contact on the website. Otherwise, feel free to add me on LinkedIn. My name is Sören Martius. You can find me there as the founder or one of the founders of Terramate. And then other than that, also our Discord. So we have a Discord server. For customers, we do shared Slack channels. But if you're just interested in getting in touch, our Discord, you'll reach me immediately.
Cool. Thank you so much, Sören. This was really great. A lot of insights into what you're building. And I'm excited to see where this is all going.
Awesome. Thank you so much for taking the time too. It was great talking to you.
Bye-bye.